Black holes. They're not just the stuff of science fiction. They're some of the most powerful and mysterious objects in the universe. These objects, which form from the collapse of massive stars, are unlike anything we encounter on Earth. Gravity so intense that not even light can escape, swallowing everything in their path and warping the very fabric of space and time itself. They're both terrifying and fascinating, destructive yet strangely elegant. But what if humanity could do the unthinkable? What if we could tame these cosmic titans and use their energy to fuel our civilization? Imagine a source of power so immense, so boundless, that it could change the course of human history. We'd have access to energy beyond our wildest dreams. An energy source that could power entire planets, propel us to distant galaxies, and perhaps even change the fundamental way we view the universe. This isn't a fantasy. This could one day be possible if we unlock the science of black holes. Today, we're diving into one of the most mind-bending concepts in astrophysics, harnessing the energy of a black hole. How could we do it? What would it take to overcome the extraordinary challenges involved? And what kind of future could emerge if we successfully tapped into one of the most mysterious forces in the universe? Strap in, because we're about to embark on a journey where science meets imagination. Let's uncover the possibilities that lie hidden in the depths of space. To understand why black holes are such a tantalizing source of energy, we first need to grasp just how powerful these objects truly are. These supermassive gravitational wells are born from the collapse of massive stars, and once they form, they grow by accumulating more mass. They are objects so dense and compact that their gravitational pull warps space-time around them, creating a region known as the event horizon, the point at which not even light can escape. Everything that crosses this boundary is trapped, making black holes both the most destructive and the most mysterious forces in the universe. But despite their eerie reputation, black holes are far from inactive. One of the most striking features of black holes is the immense energy they produce. The accretion disk, the glowing whirlpool of gas and matter spiraling toward the event horizon, can reach temperatures of millions of degrees. The friction and pressure in this disk release vast amounts of radiation, particularly in the form of X-rays and gamma rays. This process alone can radiate more energy in a single second than our sun will release in its entire lifetime. Beyond the accretion disk, the black hole itself can be an energy powerhouse in ways that seem almost unfathomable. Rotating black holes, for example, can store energy in their rotational motion. Some of the fastest spinning black holes rotate close to the speed of light, storing energy that could power entire civilizations. Just imagine tapping into that energy, using it to fuel everything from starships to entire planetary systems. So, how can we harness this unimaginable power? While the idea sounds like the stuff of science fiction, it's based on real science, though we're still a long way from practical application. One potential method is through the Penrose process, named after physicist Roger Penrose. This concept proposes that we could extract energy from a rotating black hole by sending matter into the ergosphere, region outside the event horizon where space-time is dragged by the black hole's rotation. Here, particles could split, with one falling into the black hole and the other escaping with more energy than it originally had. By carefully manipulating this energy, we could theoretically tap into the black hole's immense rotation and use it for practical purposes. Another fascinating possibility is Hawking radiation, a theory first proposed by Stephen Hawking. According to this concept, black holes aren't entirely black. They emit radiation from the event horizon due to quantum effects. While this radiation is minimal for large black holes, in theory, smaller black holes could emit far more. If we could capture this radiation in a controlled manner, we could extract energy from a black hole without ever needing to cross the event horizon. And then, there's the concept of building a Dyson sphere around the black hole's accretion disk. A Dyson sphere is an enormous structure that surrounds a star to capture all its energy. In the case of a black hole, this would mean building a colossal, energy-absorbing shell to surround the black hole's accretion disk, capturing all the radiation and energy that's being emitted as matter falls into the black hole. This structure could potentially capture vast amounts of energy, more than any other man-made system could ever hope to. But what would it take to harness such an immense and volatile source of power? Let's be clear, this is not a task for the faint of heart. Black holes are incredibly dangerous, and getting too close is akin to playing with fire in the vacuum of space. The sheer gravitational forces near a black hole could destroy anything in their path. A spacecraft that ventures too close might be torn apart by tidal forces, the difference in gravitational pull from one side of the craft to the other. Not only would the ship be shredded, but the crew would be exposed to lethal amounts of radiation. Even if we stayed safely outside the event horizon, there's still the immense radiation. A black hole's accretion disk is a deadly environment, emitting extreme levels of gamma rays and X-rays, intensities that would vaporize most materials and pose a significant risk to anyone attempting to harness the energy. The technology we have today is simply not equipped to handle the forces at play here. And then there's the ethical and practical question. Would we even be able to control the black hole's energy without accidentally destabilizing it? What if, in the process of extracting energy, we triggered an event that caused the black hole to lose mass or change its spin? Could such an event lead to a cosmic catastrophe, causing the black hole to destabilize or even collapse further, threatening our entire solar system? Despite the enormous risks, the potential rewards of harnessing a black hole's energy would be nothing short of revolutionary. If humanity could figure out a way to tap into the power of black holes, we could solve many of the greatest challenges we face. Energy scarcity would become a thing of the past, as an almost limitless source of power would be available to fuel everything from our cities to our space colonies. Imagine a world where we never have to worry about running out of energy, where humanity can expand to the farthest reaches of space and thrive in environments we currently deem inhospitable. With black hole energy, we could begin to explore space in ways we've only dreamed of. We could power starships that traverse the vast distances between stars, making interstellar travel a reality. With enough energy, we could terraform planets, creating new worlds where human life could flourish, free from the limitations we currently face on Earth. We could even build megastructures, such as Dyson spheres, capable of capturing the energy output of an entire star system. The possibilities are endless. Black holes are the ultimate paradox. They are destructive and chaotic forces capable of swallowing entire star systems. But they are also potential gold mines of energy, the key to powering the future of human civilization. Unlocking their secrets would be one of humanity's greatest achievements, a monumental leap into a future where we can harness the very forces that shape the universe.